Today we're going to take a look at law of cosines. So yesterday we looked at law of sines and we were able to use that on non-right triangles. But let's say you had a triangle like this and I said find the angle measurements. We couldn't use law of sines because we did not have a side and the corresponding angle. So what we're going to look at today is something called law of cosines, and we're not going to derive it today, but I'm just going to give you the formula and we're going to work with it. So law of cosines is a squared equals b squared plus c squared minus 2bc times the cosine of a. Now remember that all lowercases are sides, capital letters are angles, and we can swap these out. For example, if you were trying to find b squared, instead of equal to b and c, it would equal to a squared plus c squared minus 2ac times the cosine of b. The important thing here is this side in front is the corresponding angle of the cosine, and then the other sides are just whatever two sides you have there. So let's take a look at this one. Find D of triangle DEF. So DEF, little e is 12, little f is 20, and angle D is 40. And we're trying to find D over here. So we can set this up. Well, D squared equals 40 squared, oops, not 40, that's not the side length. So our other two sides, 20 squared plus 12 squared minus 2 times 20 times 12, and then it's the cosine of our angle that we're trying, the side that we're trying to find, which is D, so times the cosine of 40. Now here's the nice thing about this one. You can type this whole thing right into your calculator. So let's see if I can bring it up here. So we have 20 squared plus 12 squared minus 2 times 20 times 12 times trig cosine of 40. So we have 176.29. So if we go back to this, we have D squared equals 176.3. And how do you find just D then? Well, we have to take the square root. So if we go back to our calculator here, the square root, whoops, that's not the square root. Square root, we can go up and get that one, and we have 13.3 approximately. So D equals 13.3. And the nice thing is, now that we have an angle and the corresponding side, if we wanted to find E, we could now use law of sines. So we're going to find something here. It says find the largest angle of a triangle whose side lengths are 9, 12, and 18. Well, the largest angle corresponds with the largest side, so this is the angle we're going to find. So let's call that A. Now it's a little different here because we have all sides. Again, we can't use law of sines, so we're going to use the law of cosines. And if this is the angle we're trying to find is A, we're going to start with that corresponding side. So 18 squared equals our other two sides, 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of A. So now instead of solving, we can't type this all in, we have to kind of chunk this out. So the first thing, what is 18 squared? We have 324. Whoa. Whoa. Oh, where'd it go? Let's see. Okay. There we go. So this first chunk was 324. The next part that we're going to type in together, it's like solving an equation. We can't type this all in because we have multiplications. We're going to chunk this together and this next part together. So let's see what's 9 squared plus 12 squared. So we have 225 equal sign 225 minus, what's 2 times 9 times 12? 216. And now most people here, they like to subtract 225 minus 216, but if you were to solve an equation, 324 equals 225 minus 216x, you would subtract the 225. So this is similar to that. We're going to subtract the 225. So let's see, is that 99? Let's see, 149. Yep, so we got 99 equals negative 216 cosine of A. So we'll divide by negative 216. So we have the cosine of A equals 99 over negative 216. But since we're finding that angle, what you guys know is we need to use the inverse. So cos negative 1, 99 divided by 216, negative 216, should give us our angle A. So we can go back to the calculator here, trig cosine, 99 divided by negative 216, and we have 117.3 degrees. So we have A equals 117.3 degrees. And as soon as we have A again, if we needed to solve other sides, we could use law of sines.